Hey Jacobian jungle, John here. And in a famous online experiment, a man takes an apple and a pen and combines them to make an apple pen. But what if you take a pencil and tape and combine them? In 2004, Andrei Game and Konstantin Novoselov discovered graphene. They drew circles of graphite on pieces of tape and then cleaved the tape over and over. Eventually, they ended up with a layer of graphite 1 atom thick. This is graphene. Graphene is made of long hexagonal crystals of carbon, and each carbon atom is bonded with 3 other atoms. And each atom has 1 electron left over. This allows the electrons in graphene to travel at magnificent speed through graphene. So fast that Einstein's equations must be used to describe their velocity.
Its crystalline structure makes it incredibly strong. Strong enough that the weight of a sedan could be balanced on the tip of a pen, with the pen being supported by a sheet of graphene, and the graphene would not break. In addition, it is chemically inert and impervious to the environment. And that's all well and good, but what are its real-world applications?
Several bad puns later.
This is the atomic graphene sheet roleplay of science. Imagine I'm an electron whizzing through the graphene sheet. Really fast. The layer of boron nitrate. Me as an electron can't get through. But on the other side of the boron nitrate, there's another sheet of graphene. Now what physicists did is they induced an electric potential across the 2 sheets of graphene so that the other graphene was more positively charged. And so me, the electron, my wave function got bigger and bigger and bigger until suddenly I'm on the other side of the boron nitrate. But physicists noticed something very strange. Not all the electrons could quantum tunnel through the boron nitrate. Only certain electrons could. So, physicists, in order to explain this phenomenon, came up with a new property for particles: chirality. As an electron moving through the graphene sheet, I'll only move through carbon atoms that have their right hand out because my right hand is also out. But I won't move through ones that have their left hand out. Notice how the carbon atom on the other side is a right-handed carbon atom. Me, as a right-handed electron, can quantum tunnel through the boron nitrate to the other graphene sheet. But if I was a left-handed electron, I couldn't quantum tunnel to the other side because my hand wouldn't fit with that carbon atom. And that's the basis of chirality. A particle can either be right-handed or left-handed. So now that physicists have discovered chirality, what does this mean for real-world applications? Well, manipulating particles' properties have discovered entire new ways of storing information. I mean, electricity itself is just the manipulation of the negative charge of electrons. And now, even magnetic chips are manipulating the magnetic properties of particles in order to store more information. So chirality, like charge and magnetism, can be used to store more information. Physicists believe that chirality determines the path an electron will take through a medium. Thus, if we can control the chirality of the electrons we send through a sheet, we could be able to send basically more information, with chirality being the bit of information being received. And to think, all of this is because of graphene. Without its hexagonal shape and its great conductivity, we would have never figured out that electrons travel through separate paths based on this new property of chirality.